Hi, this is Brian Fogarty, and this is a video for Chapter 7 of the book Quantitative Social Science Data with our second edition. So in this video, what we're going to do is we are going to look at measures of dispersion for variables. So in the previous one, we looked at measures of central tendency. This goes hand in hand. This is measures of dispersion. The name measure of dispersion, it sounds like it has to be, some sort of like dorky, geeky band. I swear, like I think I saw one in the Raleigh-Durham area, but I imagine that every single college town in the U.S. and elsewhere probably has it. Either that or there's one, and that one band is like black metal. Anyway, so what are measures of dispersion? So measures of dispersion tell us how the data is spread around. We'll talk about this, but around the mean. But how spread out is the data? So it's sort of like trying to get a handle on or metric, or come up with a metric for what the frequency distribution looks like, right? So like how spread out is everything? So we're going to talk about two different ones, the variance and the standard deviation. So the variance, we can define it as a measure of dispersion around the mean, right? So that immediately implies that in order to look at the variance, we need to be able to look at the mean. In order to look at the mean, we technically need an interval ratio level variable, or again, what I say is a high ordinal, 7 categories or more, and you can get smaller as well. Okay, standard deviation, we can define it as a measure of dispersion around the mean. Wait, that's the exact same definition as for variance. So people are like, what? So what is that all about? The difference between them is based on the unit of measurement. For the variance, the unit of measurement is squared. For the standard deviation, it's not. So if we have something that's, say, measured in months, we would talk about the standard deviation as, 15, we might say something along the lines of standard deviation is 15 months. If we had, let's imagine, the variance, then it would be whatever amount months squared, right? That doesn't make a lot of sense. So oftentimes people prefer to use the standard deviation to look at dispersion and how the values are being spread out around a mean. So the one thing though is that in sort of normal conversation, as if this normally comes up, but people talk about, often will say, well, what's the variance of that variable or of the data? And usually they're not really referring to the actual value of the variance. They just mean like how spread out it is, like where are the observations laying on some measure. Okay, so the relationship between the two is that the standard deviation is the square root of the variance. Or we could say the variance is the standard deviation squared. Thus, this is where the difference in the unit of measurements come from. Okay, so to look at this in R, it's very simple. We can, for the variance, we can use the var function. So we're going to use the life expectancy data. And so let's look at the variance for females and the rounded version. All right, so we have that it's 2.29, I guess, rounded. All right, so we'd say the variance for females, or the variance for life expectancy for females is 2.29 years squared. Again, that's like, what? The standard deviation, we can just do SD. And again, we're just the same thing. We put that in there. Okay. Run that. And it is 1.51. So we would say that the standard deviation for female life expectancy is 1.51 years. Sometimes people ask, like, well, what's a good or bad value? There really isn't. It's just relative. It's just relative. It's relative to the scale of the variable, what the mean is. You know, the mean for, let's look at this again. The mean for female life expectancy is, I think it was like 82 or something around there. Okay, 81.19, 81. So a standard deviation of 1.51 is really small. So it's just like a relative guess about it. It's not, I mean, maybe there is some like real technical version, but we don't need to really worry about ourselves, or need to worry ourselves about it. Okay. The last thing I want to look at with measures of dispersion is we can do the measure of dispersion by group like we did the mean in the previous video. So I'm going to steal this code. This was in the previous video. I'm just going to put this down here. All right. And so this is from the VF England data. We are looking at the differences in age based on people's Brexit vote. So, like, what's the average age of people who voted Remain? What's the average age for people who voted Leave? So this is, again, before. What we can do here is we can add standard deviation. So we're just going to do SD age. All right, I'm going to highlight that and run that. So we'll see here, this is what we had in the previous video. Now we have another column here for standard deviation age. Okay, so looking at this, what does this tell us? All right, so Remain voters, the average age of Remain voters was roughly 48. Standard deviation of 16. Leave voters, the average age was 56. Standard deviation of 14. So again, it doesn't really tell you a great deal, but what we can kind of get from this is that Remain voters, the age is more spread out around the mean relative to Leave voters, but there's not really a huge difference there. Okay, so that's it for this video. Just wanted to do a quick look at variance, standard deviation as measures of dispersion. So thanks for watching, and I'll see you next time.